Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I'm taking a look at a question sent through by a student which asks us to evaluate the derivative of the following functions using first principles. So the first one is fx equals 5x plus 1, and the second one is fx equals 4 minus 3x. And I think what makes this question interesting isn't trying to work out the derivative, because once you've learned the rules, you could do this very quickly. I mean, clearly the derivative for part A is 5, and the derivative for part B is -3, and that's easy enough to get to using the rules. But what this question is asking us to do is actually do the evaluation using first principles. And so clearly this question is coming from the part of the syllabus, calculus, where it's first being introduced. And I think it's really important to have a very good understanding of these foundational ideas of calculus, because at the end of the day, you might get lost in all the different rules for all the different ways to differentiate different things, but you really need to always come back to what ultimately you're doing, which is working out rates of change. So what I'll do, I'll just write out what we're being asked to do. So we want to differentiate two things. So we've got, our first one was fx equals 5x plus 1. Our second one was fx is equal to 4 minus 3x. And the key for this question is to use first principles. So what I might do before actually doing the mechanics of the question is just give a little bit of background about what this is all about and what are the first principles of differentiation. Because as I mentioned, I think these foundations are really important. They're what will help you truly understand what's going on, especially as you get to the really hard questions. So I think what might be helpful is if I just sketch up a little chart here. I'll label these axes as we normally do, X and Y, but we'll kind of see it might not be the most helpful thing to do, but anyway, hopefully it's not too troublesome. And what I might do is I'm just going to draw on any old curve. It actually doesn't matter what the curve is, but I'll just draw something like that, and we'll call this curve y is equal to fx, some function of x. So we take our x value, put it through the sausage grinder that is whatever the function is, and we get some y value, and this is how it plots. Now what I might do is I'm just going to pick 2 points on this curve. I'll say the first point here is at the point x, and this is where maybe it's a little confusing, but there's some value x. X could be 1, 2, 3, whatever it is isn't really what's important. It's just that it's some value of x on the x-axis. And then I'm going to move over to this point, and the value of the function for this point is at an x value of what I'll call x plus h. So in other words, the distance I've moved in the x-axis is a distance of h. Now, the basic idea of calculus, if we wanted to find the derivative of some function, so in this case this function, at the point x, what we're really saying is we want to know what's the tangent at that point. And specifically, we want something that lets us know how steep that tangent is at any point on the curve, any point x on the curve. And the basic idea, the first principles idea of calculus, is that if you have 2 points on the curve and you draw a line between them, so you get basically this second here, this line that connects the 2 dots, the tangent of that line will get closer and closer to the tangent of the actual point, the tangent of the curve at point x. This line and this tangent will almost converge and become the same thing as h gets really, really small, or in other words, as these two dots get closer and closer together, you essentially will end up with just a single point, so that the tangent and the secant become the same thing. And so the kind of way that that gets translated into calculus is that the derivative of a function, which we can denote with f dash x, is equal to the limit as h goes to 0. And that's just our way of saying mathematically that this gap gets really, really small, so small that it eventually becomes 0, of the gradient of this secant, because as h gets small, the secant and the tangent become the same thing. Now, what is the gradient? It's the rise over the run, which you would have learned back when dealing with straight lines and gradients. So now we just need to kind of put that rise over run in a more useful format. So if I kind of draw the classic rise over run, so here the rise is the vertical distance between this point and this point. Now this point is the function at x plus h. Now we don't really know the function, so we just write it as f of x plus h minus the function at x, because that's the vertical distance we've traveled, the movement between the value of the function at x and the value of the function at x plus h. So minus fx, that's our rise. And then our run is just h, because that's how we moved. We moved from x to x plus h. So inserting both of those in, we get, it's the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. And that is the, I guess, the formula, you could call it, for first principles differentiation. Now, often it's the case that you kind of get introduced to differentiation with this formula, and you use it a few times to get your head around it, but you very quickly move on, and then you just start remembering or learning and then committing to memory all the different techniques and rules that there are for differentiating different kinds of functions. Both of these are straight lines, but you know, we can differentiate all kinds of functions. But for this question, we're going to stick with the first principles and see how mechanically you do it. So for part A, what we do is we'd say that f dash x is equal to the limit as h goes to 0 of f of x plus h, and all that is wherever I see an x, I just put x plus h. So we get 5x plus h plus 1, that's our fx plus h, minus fx, which is exactly what we were given. So minus 5x plus 1, all divided by h. And that's going to be equal to the limit as h goes to 0 of 5x plus 5h plus 1 minus 5x minus 1, all divided by h. And we see some things cancel here. The 5x and the minus 5x go, the plus 1 and the minus 1 go, and then all we're left with is 5h on h, so the h's go, and it all simplifies down quite neatly to the number 5, which is what I had mentioned at the beginning of this video, because I know the rules, so even without using first principles, I can see it's 5 times 1, x to the 0, which becomes 1 plus nothing, so you end up with 5. But this is the long way, I guess you could call it. So that's how you do part A. Maybe just over here, I'll do part B. So here, f dash x would equal the limit as h goes to 0 of fx plus h would be 4 minus 3x plus h minus 4 minus 3x, and that's all divided by h. And then that's going to be equal to the limit as h goes to 0 of 4 minus 3x minus 3h minus 4 minus minus gives plus 3x, all on h. And here the 4 and the minus 4 cancel, the minus 3x and the plus 3x cancel, and then we've got negative 3h on h, the h's cancel, and we're left with just negative 3, which again is what I mentioned using the rule that I know is what I know is the right answer. So in both cases, the first principles have got us to the right place, so that's good news. But really the key to this question wasn't really about getting the answer, because this isn't difficult in terms of calculus once you know the rules. What this is really trying to get us to grapple with is understanding the basic foundational concepts. And I think a chart like this is often the way you'll see it introduced. And the key to understanding, the key idea is to know we're ultimately just finding the gradient of a tangent at a certain point. And the way we can find that in general is to note that the gradient of the line between 2 points converges to this tangent as the distance between the 2 points gets smaller and smaller and smaller. Sonic boom! So hopefully that makes sense. Hopefully that kind of idea of the foundational concept is starting to become clearer for you. If you found that explanation helpful, please be sure to give the video a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom!